Have you ever been bit by a mosquito? Well, you better be careful because mosquito bites are the vectors of potentially serious diseases including malaria, West Nile virus, dengue fever, and chikungunya fever. Insect bites are very common and usually only cause minor irritation and a small red bump. The most frequent source of insect bites are from insect, bees, mosquitoes, fire ants, and ticks. Now, how do we prevent these insect bites and protect ourselves against any diseases they could spread? Good day, viewers. I am Mary Lou, first reporter of Group 1. In this video, we are going to talk all about insect repellent, an ideal insect repellent, and how does it work. Insect repellents are agents that are used to protect the body from the bites of insects that can cause local or systematic effects. Watch ERYKA up next to dig more about insect repellents.
Do you know that there are two sorts of insect repellents? Insect repellents currently fall into two categories: chemical repellents and natural plant-derived repellents. The most well-known and well-used chemical repellent is DEET, or N,N-diethyl-3-methylbenzamide, previously called as N,N-diethylamtoluamide. Picaridin, a repellent made of piperidine, is the most recent chemical agent to demonstrate its efficacy as DEET. Because of their low toxicity, plant-based insect repellents are gaining popularity but haven't been proven to be as effective as DEST. Soybean oil, canola, and eucalyptus products are a few of these. Insect repellents may be divided into two basic chemical classes. The first class are the synthetic chemicals such as DEET, picaridin, and IR3535. The second class are the plant-derived oils and synthetics such as oil of lemon eucalyptus, oil of canola, and permethrin. What is an ideal insect repellent and what should I aim for? Well, insect repellents should aim for active against a wide variety of biting insects, prolonged activity, non-irritating to the skin and mucous membranes, cosmetically appealing, no systematic toxicity, resistant to abrasion, washing and sweating, chemically stable, doesn't react with commonly used plastics, and be economically viable for widespread use. Now, here's CHRISTIA to give more information about insect repellents.
As of now, there are no insect repellents that meet all the standards ERYKA mentioned. It is exceptionally hard to find a single active chemical that is effective against the many different species of disease-carrying insects. DEET is the most extensive and effective insect repellent that has been developed to date. Nevertheless, it has been discovered that the chief malaria-carrying mosquito, Anopheles albimanus, or common malaria mosquito, in the US is becoming reluctant to DEET. How does insect repellent work? Well, first things first, we have to be knowledgeable about how biting insects find their host. Insects use a combination of sight, heat, and smell to locate blood meals. They're attracted to the smell of carbon dioxide, or CO2, lactic acid, and other odors from the skin, whether it is warm and moist. Commonly, insect repellents, including DEET, work of the principle of creating a vapor barrier that deters the insect from coming into contact with the skin. To the insects, vapor smells offensive and tastes awful. The olfactory biology of the major malaria-carrying mosquito Anopheles gambiae is currently being studied by researchers with the International Anopheles Genome Project. Mosquitoes use their olfactory binding proteins, or OBPs, to recognize human-specific scents given out by human skin in order to host to feed on. According to scientists, eliminating mosquito OBPs should prevent them from choosing human as their host and significantly reduce bites. Did you know that insects have been present for about 350 million years and humans for only 300,000 years? Cool, isn't it? That's all for today, everyone. I hope you learned something.